Let's start talking about the buzzer. The buzzer we're talking about is the piezoelectric buzzer. And this buzzer uses the principle of piezoelectricity. Now, what is a piezoelectricity? A piezoelectricity is the electric charge that accumulates in certain solid materials, such as crystals, certain ceramics, in response to applied mechanical stress or pressure. So this picture here is the main component inside a piezoelectric buzzer might look like. And actually this component, you can actually find this in many different places in your house, such as in smoke detectors, places where the devices that make a beeping sound, nowadays most of them use piezoelectric buzzer. Now, piezoelectric buzzer, this is this is the main component, and this component actually, you see, this is two pieces of metal. In between the metal, you see a ring-shaped material, like a little whitish material. I believe this one is some kind of ceramic, and not just any kind of ceramic though. Is the kind of ceramic that uses particular kinds of materials, and those materials have good piezoelectric properties. And how does that work? In the idea of the piezoelectricity is illustrated in the little picture below. And let's say this orange bar is sort of the piezoelectric material. And then you may have a piece of metal that's put next to it. This metal, in fact, just kind of compare this with this picture right here. So you can think of this orange bar as the ceramic, the piezoelectric ceramic, and the little metal plate in the middle. This is basically called a diaphragm. And this diaphragm, when it gets squeezed, it will basically bend. It will bend because there's no other place to go. It will simply bend. When it's bending back and forth, and this is what's making the sound. And so how does it bend back and forth? This is because when we apply electricity on this piezoelectric material, the ceramic right here in the middle, depends on the direction of the electricity, it will basically bend in a certain way. And the idea to have this making sound so that it squeezes the diaphragm in the middle in back and forth in different directions, then you would basically apply alternating current to this device here. So that's kind of the principle here, how that kind of works, okay? And what might look like in the piezoelectric buzzer, or piezo buzzer for short. This is a possibility, what might be inside that buzzer. So this has a little circuit inside. And this is the circular piezoelectric material mounted with metal plates. You imagine this is the thing. The PZT, by the way, is a specific material, mostly commonly widely used actually material in the piezoelectric ceramic. Now, not necessarily this is exactly what's in the buzzer that you have now, but this is a possible implementation, so to speak. And then you use some resistors here, well, not the resistors, the transistors here to basically give it a alternating current on this so that it won't be able to make that sound. And this basically is the idea there. Now, the piezoelectric principle, as we just shown, it can make a fine alarm, right? You can, even in your computer, it makes a beeping sound. In the smoke detectors I mentioned, or maybe your washing machine or your microwave, many places where this piezoelectric buzzer might be used. And if we need some kind of accurate measurements of certain properties of the environment, so we can actually make a sensor by using the piezoelectric principle. So the sensor, piezoelectric sensor, is a device that uses the piezoelectric effects to measure changes in pressure, acceleration, temperature, or force by converting them to a electrical charge. So the piezoelectric buzzer is an output device. You give it electric charge and it makes a sound. Now, we can also make an input device, and I kind of just mentioned this right here. We're not really focusing on this, and we're probably not going to actually study this in details or we don't even have this part in the kit. But I want to mention this together with the piezoelectric buzzer. And this, you can make an input device, which is the sensor here, that gathers the physical environment property and convert that to electrical charge so you can measure certain things in the environment. And this symbol, we're just using the previous chart diagram. This is actually the schematic symbol. Typically, you'll see this is actually representing like a crystal in the middle. Now, you can use a crystal, you can use a certain kind of ceramic. Those are the common kinds of piezoelectric materials. In fact, the material that's actually have the piezoelectric effect, and not only include those, but also even organic matters such as bones or DNA, they also can exhibit such a property. So it's an interesting thing that we're able to apply. This is a good technology. Now, let's switch to the current. Now, using the buzzer is fairly straightforward. So I'll skip the freezing diagram. And so take a look at this, right? You have this in your bag. Let's hope you have a good review here. Okay. So this one, there's a little hole on the top of it, so the kind of sound can come out instead of a muffled in this packaging, this plastic packaging here. And there is a plus symbol marked here. This is actually marking which lead is the positive or the anode lead, okay? And so the rule is similar to the LED. The longer lead is the positive lead, all right? So it's still the same thing. And so even this marked, even if it's not marked, you should know. Now, to connect this to the breadboard is fairly straightforward. Now, because this is, it's kind of a big, and once you push it in, you kind of hard to see which holes have the pins, right? These where it goes to. So I typically pick there's basically you see on the right hand side, these are the places where we're gonna plug into the ground. So the shorter lead goes to the ground, right? The ground is negative. And I'll usually pick there's a sets of 5 rows, right? This sets of 5, as you see those things, and there's a gap in between. So I typically just align to either the first or the last one so that, I know where to plug in my jumper wires. So let me connect this. So the shorter lead goes to the ground, which is in this column, okay? And then it's just wide enough to push this into the, basically, the last hole of this sets of 5 holes on the board right here. And so I have this jumper wire here that connects back to one of the GPIO pins, okay? So in this case, I chose the GPIO 22. Now you can use any one of those. Okay, so this gives a 3.3 volt charge, and then the electricity flows through this buzzer and then back through the ground. And it's very straightforward. So you just connect that way, it'll make a sound. And then so the way, now let's look at the program. Okay. For this program, I like to use the same example we have used for the single color LED. We use that LED to send message in Morse code. And we just kind of show you what we had before. We have a class LED Morse code generator. And this kind of has the hard-coded LED objects when we initialize or construct the object of this class. And LED is an output device, and so is a buzzer. So we actually, the library GPIO0 implements both as subclass of, if you actually look into LED, if I just kind of click into this, you see LED is a subclass of digital output device, all right? And in fact, buzzer right below this in the library, it's also a subclass of a digital output device. They are very much similar. Think about this. One is converting electrical energy to the light energy. And then the buzzer is converting electrical energy to sound energy. So they are very much equivalent, except they just convert into different. One is using light, the other one is using sound. So we can generalize instead of, because the logic of transmitting Morse code and then how to encode and decode is the same stuff. You don't want to repeat your code. So there's this principle in programming. It's called dry principle. Don't repeat yourself, dry, D-R-Y. So for the DRY principle, we want to generalize this class a little bit. And the way to do that is not to assume it's going to be an LED. So instead, we pass an additional parameter to the constructor. Say, what is the device type? Okay, so you're going to pass that LED class or the buzzer class to the initialization so that it'll make an object of that class. So this is a one simple way to generalize in this case. Now, as you know, this is the type hint here. The type hint, I'm using this type class from type-in library. And then you give it the, this is a saying, this type has to be, basically either is a digital output device or a subclass of it. So this is a kind of just a documentation purposes. Python doesn't really, enforce it. But as I said, this is a good habit. It's a very important documentation. Now, in fact, since we have changed this to call it device type, here at the original variable name is still called _LED. Perhaps we're gonna, probably it's a good idea to change this also. let's see, let's change this to the LED object. Let's change this to, output device. How about that? Okay, so that is generic in that sense. And everything else remains the same. So this class, now we're gonna name it a Morse code generator, okay? You use this blink method. Now this blink method is actually available, not, this is available not just for LED, this is actually available on the digital output device, by the way. So LED call this blank, all right? And if you actually see a buzzer has a method called a beep. It's simply just an alias of blink, kind of just makes us call it beep. That's it. So the blink works for either LED or buzzer. Okay, this is still the same thing. So we're going to use that. And then once you have this refactored, and then the code for sending a message SOS, which is a pro sign, using the buzzer, is simple as this. We'll make an object or Morse code generator. We're going to pass the buzzer class to it. So this is want to use a buzzer to send a Morse code. And then we're going to pass the pin number, which we're using 22 right here. And then we transmit message SOS, and pro sign is true. Okay. So that's that. Okay, let's try this. Let me turn on the Pi. And well, I'll show you the circuit there, although you're not going to see anything visually, but it will just make sound. And let's see if I can record sound. All right, let's hope that it will record sound. All right, let me run that. So first I'm going to connect to the Pi. Well, actually, let me mute that one first. And then once I get to run this, I'll unmute. Okay. Now the process of connecting to the Pi is the same as I've shown you many times now. Okay. All right, let me unmute and then run the program. That's it. So basically, now we're using the buzzer sound signal to send SLS. So it's basically the S is three short, basically the dots, and then you have three dashes. You have the three dots again. So it's like basically the short beep, long beep, and then short beep. So that's kind of what this is. In fact, this is probably closer to how the telegraph works. And telegraph uses sound when the signal is sent through. This is kind of how the original worked. So that's really it about the buzzer. And this is going to be a useful device that you'll probably use in your future projects. Thank you.